Hi, I'm Mark Fernandez. BZAR was a fun project to work on. It started as a little internal research project within MITRE, and it was inspired by a colleague of mine who worked at a different company, and he was, gave a presentation stating a lot of the themes that we've heard today. Don't focus on indicators of compromise, those things are too easy to change. Focus on adversary behaviors. He was using a lot of the language, very similar language, similar terminology to attack, but he didn't quite frame it in the attack model or in the attack language. And he was using another tool, and I was more familiar with Zeek, and I wanted to do something very similar. And he was saying, hey, take these concepts and employ them yourself. So I applied for, submitted a little research proposal within MITRE, and with the attack name and open source software, open source contribution, I think it was a really easy decision. Almost got like a rubber stamp from MITRE, and that allows John and I to be here today to present to you.
All right, and I'm John Wunder. I'm a cybersecurity engineer at the MITRE Corporation. I've been working on attack for a few years now. My focus is specifically on the detection side, if you're familiar with MITRE Cyber Analytics repository. That's one of my projects. That's also how I got hooked up with Mark. Mark was working on this thing called BZAR, was looking at detecting attack behavior. I was running this project called CAR that was looking at detecting attack behavior. And so we figured we should talk, and that's how we ended up here. All right, so we are the last talk of the day. So what is standing between you and apparently a big old place of beans and rice, I guess is the thing? So what do we got? So first, we will talk about the matrix. I know it's been mentioned a bunch here, and a lot of people have touched on it, and it's great that so many people are using it. I did want to do a little bit of level setting and talk about what is it fundamentally, and what has made it so successful such that people are mentioning it ahead of time. Second, we'll talk about threat hunting with BZAR, with Mark's project. He'll go over a couple examples. And then we'll end on some takeaways and questions. So what is attack? Normally when I explain attack, I use the pyramid of pain as an analogy. We have the OG here, David Bianco, so I don't think I need to cover it. But what attack is a knowledge base of the things that adversaries are doing when they attack us. What are the fundamental behaviors that they use when they are attacking our systems and networks? So it's those TTPs. If you are familiar with the pyramid of pain, it's those things at the tippy top of the pyramid of pain that in theory are harder for the adversaries to change. And attack is a knowledge base of those things. So it's worth, I think, thinking about what has made attack as successful as it is. What are the features in attack that make it useful for us as threat hunters? So one thing that I think is great about attack is that it's based on real world observations. It's based on open source threat intelligence that is not just a theoretical way of how the adversaries might attack us. It's a way that attackers have actually attacked us in the past. It's things they've actually done with references to when they actually did it, who they did it to, and things like that. Second, free is obviously great. Everybody loves things that are free. You can get to attack now and in the future at attack.mitre.org. And it's a database that everybody can use. And I think that's what's made it really great as a common language. So you're here at the Threat Hunting Summit, and you're hearing about MITRE ATT&CK because it's been really useful for threat hunters. We heard about how John Stoner was formulating his hunt playbooks around it, or formulating his hunt hypotheses around it. If you go to the SANS Cyber Threat Intelligence Summit, you'll hear how people are using it to formulate threat actor profiles, or the threat library team, as they talked about. They're using attack for that. So it's this common language that lets us talk between different functions and also between different companies. And because it's achieved that uptake, it's also community-driven at this point. So MITRE maintains attack, but if you look inside attack and look at the content in there, in the most recent update, 70% of the stuff that was added was actually contributed by folks like yourselves, probably including many of the people here, told us, hey, here's this thing we're seeing actors do. Here's the report that I published on it. Can you get that added to attack? So those, I think, are some of the things that have made attack successful. But you're probably more interested in what is attack. Many of you probably know this. Again, this is just some level setting. So this, if you've ever seen anything about attack, you've probably seen this. This is the attack matrix. And across the top of the matrix, we have tactics. So the T in TTPs stands for tactics. The way we think about that is the adversary's technical goals. So the things that they want to achieve when they're on our systems and networks. They want to achieve initial access. They want to get in. They want to move laterally. They want to achieve persistence. And then eventually they need a command and control channel. They want to collect some information and then exfiltrate that information. So these are the things that they want to do. And then, of course, they have different ways of achieving those things. I always miss the clicker by one. These are the techniques, so the ways that they go about achieving them. So if you look inside credential access, for example, there are different ways that adversaries can get access to credentials. They can pull them from memory from LSAS. They could also look in the registry. They could look in files. They could try brute forcing them. There's all these different ways that they could get access to credentials, and that's what we think of as the techniques, the second T in TTPs. And then if you look inside each of those boxes, if you go to the actual web page, these are all clickable and there's lots more information there. But for our purposes now, the P in TTPs, procedures, describes exact ways that adversaries have done this in the past, even down to the command line level. What are the exact things that they did? So in this example, a spear phishing attachment might include a Word document with DDE, or it might include a Word document with macros or something like that. So it's just more specifically, what exactly did they do? And the other thing I would call attention to on this slide is that if you look at the tactic columns, it may not be super readable, but on the left we have initial access, and on the right we have things like command and control and exfiltration and whatnot. But there's a whole lot in the middle there. There's a whole lot of things the adversaries are doing when they're on our systems and networks that is totally invisible to things going on around the outside, right? So if we look at those tactics again, the middle, so that chunk in the middle is the most important thing for our purposes right now. It's how do we look at them, not just after they get, not just when they get in, not just when they, not just as they're getting stuff out and as they're doing command and control, but what are they doing to us while they are in our systems and networks? And what we have to ask ourselves as threat hunters is A, how do we see those behaviors? What evidence do those behaviors leave on our systems and networks that we can then go look in? And B, of course, how do we look inside that evidence to find the needle in the haystack and find not just, there was PowerShell, but this was malicious PowerShell. This was an adversary using PowerShell. For this talk, though, I think a lot of the focus is going to be on the left side of that. It's how do we see the behaviors? What is the evidence that we can see? Eventually, this will work. There we go. All right, so if we look at the tactics, so this is those blue things at the top. If we look at these tactics and we ask ourselves, what can we see? As I talked about, we're really interested in the stuff in the middle. And if you look, perimeter monitoring, so the typical way that, if we went 10 years ago, what a lot of people were doing, looking at firewall monitoring and network monitoring, that would let us see maybe that initial access, command and control, and exfiltration. It lets us see the things that are, transiting our network boundaries, right? The ways in and the ways out. And so that's why we've seen the industry move over the past few years to really do a lot of endpoint monitoring, to really look at not just what is happening on our boundaries, but what is happening within our companies on our endpoints. And so that's colored in these other boxes, right? But defense in depth, right? So it's not just about having one way of detecting the adversary. We want to be comprehensive with what we're doing. And so endpoint monitoring is great. Endpoint monitoring is not perfect. I think we saw in the presentation earlier about Sysmon, it's possible for an actor who's on your system and is an admin to disable Sysmon for you. So that means we're going to be missing things. Not all of your endpoints will have Sysmon enabled. If you have unmanaged endpoints, or if there are endpoints that you don't know about, your endpoint monitoring is probably never going to be perfect. And so you're always going to be missing things that way. And the adversary can evade things on the endpoint. So if you're looking for PowerShell.exe, they could rename it. That's a trivial one. They could also just not use that binary at all and use an API call. And so endpoint monitoring is great. I think we should absolutely keep doing that. That is what I focus on. But when I was talking to Mark, I was hearing all about internal network monitoring, what they're doing looking not just at the endpoint, but also what is going on between the hosts in our network. So here, by internal network monitoring, this is also sometimes called east-west network monitoring. It's looking at not the traffic coming in and out of your organization only, but also between hosts in your organization, between the desktops and the servers, or between the servers. And so if we look at these tactics and we say, okay, what can we detect with internal network monitoring? Well, which one jumps out at you? I think there's one obvious one, right? Lateral movement. Yeah. Talking to Mark, it turns out it's not that simple. There's many more, and there's also challenges in detecting lateral movement. And so I'll turn it over to him to cover that.
Thanks, John. So internal network monitoring is a good thing. But of course, you can have too much of a good thing. And there lies the problem with this project, is that internal network traffic can be very noisy. There's so much activity, there's legitimate authorized activity that generates overwhelming volumes of network traffic in your network. And in a Windows environment, there's two very common and very powerful networking protocols. Server message block, or SMB protocol, that facilitates things like file and print sharing, mapping network drives, and remote procedure call, or RPC protocol. Now, almost every system service in the Windows operating system has an RPC interface associated with it. And Windows has a lot of system services, many of which can be accessed remotely via the remote procedure call. When you do a deep dive into the technical specifications of these two protocols, that's when you quickly realize you could detect a lot more than just lateral movement. Execution, for one, things like the task scheduler service or the Windows Service Control Manager has RPC interfaces and networking components to it. And if you keep digging into these network protocols, you start to see you could detect a lot more, things related to persistence or defense evasion, credential access, and discovery. So as part of the BZAR project, I needed a tool to help dig into these protocols further, to help reduce the noise and allow me to focus on the aspects of these protocols that I care about most. So the tool that I use, I was very familiar with it. It was the Zeek Network Security Monitor. It used to be called BRO. It's been around since the 1990s, so more than 20 years at this point. A couple of the key benefits to Zeek is that it is an open source software tool. And it's highly customizable, which means that if there's a function I need and Zeek doesn't already do it, well, I could just code it up myself and build it into my instance of Zeek, and now it does what I need it to do. Also, it provides deep packet inspection for a great number of network protocols, including SMB and RPC. So that was a very beneficial and very powerful starting point for the BZAR project. So BZAR, B-Z-A-R. So the key to any, I think, successful project is to have a catchy and memorable acronym. BZAR stands for BRO-Zeek Attack-Based Analytics and Reporting. It's also a play on words for bizarre, meaning something very strange or unusual, especially as to cause interest. So I thought that definition or that meaning was very applicable to this project. And what exactly is BZAR? What do you get if you have BZAR? Well, it's a collection of open source scripts for the Zeek security monitoring tool. And we posted it earlier this year on the MITRE attack page on github.com, MITRE attack BZAR. It has the collection of BRO scripts or Zeek scripts there. So before I dive too much further into BZAR, maybe, again, to level set, maybe not everybody's familiar with Zeek or BRO, so just wanted to talk a little more about it. If you are familiar with it, you realize it's a very powerful tool. It can do a lot of great things for you. To boil it down into 20, 30 seconds, it monitors network traffic, and in the core of the program, it'll analyze the packets as they're coming through, and it'll raise an event once it sees something. Hey, I've seen an HTTP packet. Hey, I've seen a header line in an HTTP packet. I've seen an SMTP message. I've seen the to line in an SMTP message. It really decomposes the network protocol into these events, into these manageable pieces of information, and it provides a lot of state with the connection as well. And then on the other side, as an analyst, I don't have to worry about all the technical details of how they implement the protocol analyzer. I would write an event handler for the different events that I care about. So in my case, I care about SMB protocol and RPC protocol. So if there's an SMB write packet that goes across the network, Zeek analyzes it, it raises an event. I have an event handler that says, tell me a little more. What's the context of this SMB write? What's the source? What's the destination? What's the file path on the endpoint where the write is occurring? Is it to a file share, to a print share, et cetera? So there's a lot of information like that Zeek gives you access to. And looking at one of the starting points of this project was looking exactly how much information can Zeek give me. So looking at what it does in the SMB Protocol Analyzer, Zeek identifies 145 different message types. Now, if you're familiar with SMB, there's SMB commands, there's subcommands, there's a whole lot of different ways that the information is sent across the network. So there's 145 different message types, which is a lot. And you look at the RPC Protocol Analyzer. Now here I have DCE RPC because there's a couple of different flavors. There's the old SUN RPC, and Zeek has one analyzer for that. And DCE stands for Distributed Computing Environment, which is an open standards group, and they developed the original RPC specification, and Microsoft adopted it years later. When you look at their RPC Protocol Analyzer, they identify 81 different RPC interfaces and more than 1,400 different RPC methods. Now, you could think of an RPC interface kind of like a Windows DLL, It's a library and it exports a lot of functions. And you could think of the RPC methods as like one of those functions that's being exported by the DLL. So an RPC interface provides a lot of different functions that are exposed. And again, those are a lot of numbers. Those are a lot of information, which leads to some other questions, right? So how many SMB message types are there in the Windows operating system? How many RPC interfaces exist in the Windows operating system? How many methods exist in Windows? There's a lot. I could talk to you afterwards. I forget the numbers exactly. I think there's more than 300 total SMB commands that Zeek that are in the Windows operating system, and more than 2,500 different RPC interfaces. And I stopped counting after that. But there's a lot of opportunities to map these things to different attack techniques. And a couple of bonuses with Zeek. It also has authentication protocol analyzers for different authentication protocols like Kerberos, GSS API, Windows NTLM, and those authentication protocols are used for SMB and RPC authentication. And another bonus, I'll put that up there now, another bonus that I didn't think about initially that I was able to take advantage of during the development was Zeek has a file extraction analyzer. So in any of the network streams, if it detects a file's going by, whether it's the file transfer protocol or a file being transferred in HTTP, or in the case of this project in SMB, there's an option, and BZAR takes advantage of it, that says, go ahead and make a copy of that file and save it locally to the Zeek device, because I think that'll aid my incident responders down the road. If that turns out to be a malicious file, well, now I have a copy of it. Zeek has a copy of it as that file was going across the network before it actually got onto the victim host. So that was a great advantage, and that's why I say that was a bonus, because I didn't think of that when I initially started, but it definitely took advantage of it. So here's the attack matrix. The orange cells are the ones that I say there is some confidence of detection, that BZAR can detect those techniques. And when you dig into each of those, like John was saying earlier, there's a lot of different means or mechanisms, procedures by which those techniques can be achieved. So maybe BZAR doesn't detect all of them, but it'll detect some of them. Less than 100%, more than 0%. And this chart is really hard to see, though. So let's advance to this one, where it focuses on just those orange-colored cells. And you see there's technique categories or tactic categories of execution, persistence, defense evasion, credential access, discovery, and lateral movement. There were a few more tactic categories on the previous chart you might have seen, but it's only because these specific techniques maybe span multiple categories or multiple tactics. And there's a lot here that I could discuss, and for the purposes of time, we'll focus on lateral movement and service execution. And here's an example, kind of what you could see with the network traffic. So when you look at the attack model, there's some techniques that, as we were talking earlier, that if you're doing internal network monitoring, there are some techniques that will necessarily generate network traffic. So remote file copy under lateral movement, that's a great example. Yes, remote file copy, it's in the name. In order to get a file from one machine to another, that's going to generate network traffic. And then there's other techniques that maybe aren't normally executed, or you wouldn't imagine they would be executed over the network, but they could be. So an example of that is service execution, the Windows Service Control Manager. There's an RPC interface associated with it, and if you're starting or creating a new service, you access the Service Control Manager, and you would imagine that would be done locally on the box that's being exploited. Well, the Service Control Manager can also be executed remotely, so there are some cases where you might be able to see evidence of that network traffic, and that's what BZAR is looking for. So let's focus on service execution. Let's look at that example. So BZAR uses 4 RPC functions as indicators of remote service execution. You look at, oh, there's a laser pointer here. How do I use it? Never mind. SVC-CTL, that's the RPC interface for the Windows Service Control Manager. And there's 4 specific functions that I focus on. Create service A, create service W. Now the A and the W is just how the character set is represented, whether it's ASCII or wide character Unicode. There's create service and start service. So if BZAR sees RPC access, RPC traffic going to that RPC interface and that RPC method, it's a really simple analytic. So maybe analytic is is a generous word to use. It just says, I presume that's bad. If I see remote service execution in your environment, I'm presuming that's bad. It's suspicious. You should look into it. And it's going to log that event. And what does that look like within Zeek? I talked about earlier, Zeek has event handlers, or the protocol analyzers will raise an event, and then me as an analyst, I have my Zeek scripts, and I have a handler for that event, and I do apply my logic based on the information that it provides. So there's two event handlers or two Zeek events that are applicable in this case. It's RPC request and RPC response. For the case of BZAR, we focus on the RPC response because that means that, hey, the service request or the create service or the start service, that was already sent to the target host, and now the target processed that message and is responding to it. So I'm going to focus on RPC response because that means the victim actually received it and processed it. And that's more dangerous. So what do you see? What do you see in the logs? So Zeek has a bunch of different logs, many of which are specific to the certain protocol analyzers. And then it has something else called a notice log. And usually things of a suspicious nature, things that you should take notice of and maybe respond or react to are written to the notice log. And a lot of times, maybe organizations can't ingest the protocol-specific logs into their SIM because internal network traffic, as we said, it generates a lot of volume, so maybe that's too much. So they focus on certain ones. So BZAR says, well, let's write these alerts, whatever I see, let's write that to the notice log. So if the organization is limited and can only ingest 1 or 2 Zeek logs into their SIM, we'll make sure the information is in one of the logs they can consume. And what would you see there? You'd see a statement like attack execution, and then you'd see the name of the RPC interface and the RPC function. In this case, service control, start service W. It would contain the IP addresses, it would contain the TCP and UDP ports, and then Zeek has this thing called a connection ID. It's a unique identifier that it applies to every connection that it sees. And that helps you cross-reference with other events and other things that are in the different Zeek logs. And that's all good, but one of the things, probably the most important thing so far, is that this must be tuned for your environment. So let's say starting a network service remotely is okay in your environment. That's fine, that's normal, that's legitimate activity, or maybe it's okay for a subset of your workforce, maybe just the system administrators are allowed to do that. So you would want to whitelist that activity, otherwise you're just going to have a lot more noise in your logs to have to go through. And BZAR at this time has some whitelisting capabilities. It's not the best. It's one of the things we're working on now, and hopefully in the next couple of weeks we'll release an update to make it a lot more granular and a lot easier for you to whitelist different activity. So going back to the example of lateral movement. So this one's a little more complex in that it's coupling remote file copy and Windows admin shares together. So there's 2 SMB commands of interest. There's the older SMB version 1 protocol, and back around the time of Windows Vista, Windows 7, Microsoft revamped SMB because it used to be very complex and very convoluted. They tried to simplify it a little bit, release SMB version 2. Both of them have a write command, and that's what we're looking for. Those are the Zeek events that BZAR looks for. And the analytic, it's more than just finding an SMB write. It's trying to find an SMB write to a Windows admin file share. Now, if you're familiar with Windows admin shares, there's 3 of them. There's admin $, and C $, that allow you remote access to the file system. And then there's IPC $, which stands for inter-process communication. And that pertains to named pipes. And that's usually an indication of, well, someone's doing RPC traffic across this named pipe. But we have so much better indicators to detect or granular information for RPC activity that we could just ignore IPC $, and that helps cut down on a lot of the noise. So we're focusing on remote file copy to the file system of a remote box via the Windows admin share. So we focus on admin $, and C $, and ignore the rest. And what does it write to the notice log? So you'll see something like attack lateral movement, and then a statement like SMB file write to an admin file share. It'll have the IP addresses, the TCP, UDP ports involved, the Zeek connection ID, and it'll have the full path and file name on the target host where that file was written, because it's able to extract that from the network protocol information. And it would be in the universal naming convention format, so // host name, / and then the file share, whether it was admin $ or C $. And then it would have the path on the box and the file name of where it was written. So that's really good information for your incident responders to have that, so they know exactly which machine to go to and which folder and which file to go to on that box of some suspicious activity. And even more, when you couple this with the file extraction analyzer with Bro, you also can have a copy of that file. So you know the name and path on the victim box where it was written, and Zeek was able to pull that out of the TCP stream as it was going across the wire. So you have a copy of that file again, which can aid incident responders, because by the time, on some occasions, by the time your incident responders get to that box, perhaps that file is already deleted or overwritten. It's not available for forensic examination. So that's a helpful one as well. And perhaps the best part, or maybe the most powerful analytic that it has, is to say, well, if BZAR movement and execution, one of those execution techniques and this lateral movement technique, if you see that occurring endpoint within a specified time frame, whether it's 5 seconds, 30 minutes, whatever you specify, that's really dangerous. That's what I care about most. Because we talk about tuning it for your environment. You could say, hey, you know what? Lateral movement is okay in some instances, and remote execution is okay in some instances. And you might want to whitelist those activities individually. But if I see lateral movement and execution occurring against the same endpoint in a short time window, that's what I really care about. And that's what I'm going to jump to action and send out my incident responders to go investigate. So with the whitelisting, you can help tune it for your environment to help reduce the noise. And so, all of this is good, and I talked about the notice logs and being able to ingest that. But really, if you can afford to bring in the RPC logs and SMB logs into your SIM from Zeek, you really don't need BZAR at all. You could apply the same logic that BZAR uses. You could apply it in your Splunk or your ELK or your ArcSight. You could apply that logic if you could bring in the SMB and RPC logs, because all of that information is there. The write activity, the file share activity, remote execution, all of that would be available in those logs. You just need to parse it out. So you could use BZAR as kind of a proof of concept so that you could implement it yourself in your SIM, or you could use it as an operational tool that you would have to tune for your environment. And I think that kind of wraps up the technical details.
Yeah, so I guess what's the bottom line out of this? So one is that I don't think anybody would say you should stop monitoring your endpoints. This is not a replacement for that. We're just saying, think beyond the endpoint. Think about what you can do with east-west network traffic. Maybe it's use BZAR. Maybe, as Mark said, if you already have Zeek, you can pull that directly into your SIM. Just don't forget about network monitoring. I think sometimes as threat hunters, we get too focused on the things that are happening on that box itself when there's many more data sources out there. So just think broadly about all of the data that you have access to or that you could have access to. Second thing, I learned a lot in talking to Mark that not everything is going to be lateral movement that you can see. There's a lot of these RPC things that really are different attack techniques that can occur across the network. They don't always, but they might. And so don't think that you're just going to find lateral movement by looking at this east-west network traffic. It's something beyond that in some cases. Second thing is look at different levels of, or third thing, I guess, is think at different levels of abstraction. So these low fidelity indicators can be added up to something more important than that. So this low fidelity indicator for lateral movement for Windows admin shares, you can combine that with either another Zeek alert or with your endpoint alerts and think about building up a broad picture, not just of what your endpoints are doing, but the network traffic that they're creating, both externally, of course, but also to other hosts on the network. And hopefully you can build up some picture of how suspicious that host looks based on all of these analytics working together. Lastly, like I said, integrate this into an overall monitoring approach. What that means is you need to pull all this information together. Let's not silo our network data from our host data. I think sometimes, even if we have a SIEM, that can happen, is that they get too separate. Some organizations I've worked with even have totally separate teams looking at network and host, and I think that can also be a mistake because we don't tend to see these overlaps if it's different people doing that job. Lastly, tune for your environment. I think we all know this, but everybody's going to have a different environment, so what works really well for one organization may not work for another.
Thank you.